Okay, looking at problem 9 on the document, we're writing the consonants and the prime digits and the 5 characters on cards. So we're going to make sort of a deck of cards. Rationale for this type of problem, the publisher's test bank and the problems in the text often rely on standard decks of cards with the 4 suits and the denominations and so forth. And not everybody is equally familiar with the nature of a deck of cards. Some people don't play cards. And I think that gives people who play cards an unfair advantage. So we're leveling the playing field a little bit by doing this sort of thing. So what I've represented here is the 21 consonants, B, C, and on down to Z. There are 21 of them, naturally omitting the vowels. And then we have the prime digits 2, 3, 5, and 7, and then the 5 characters. So we imagine these are cards, and we've written these things on the cards, okay? So we have how many? We have 21, and 4 is 25, and 5 is 30, so there are 30 cards here. Now, the question 9 says, if we pick 5, how many of the 5 card hands that we could get by picking 5 of these cards would have exactly 2 characters? Now, I'm going to solve this problem here, but first I want to get us oriented a little bit. We want to first see, well, how many 5 card hands could there be? Well, we're going to pick a card, okay? We can get a 5 card hand by picking 1 card at a time. So there are 5 steps. Pick the first card, pick the second, pick the third, and so forth. Now, if we pick the 5 of the 30 cards in order, first, well, if we pick them in order, there are 30 choices for the first, 29 for the second, 28 for the third, 27 for the fourth, and 26 for the fifth. But if order doesn't matter, then any given ordered selection of cards could appear in 5 factorial possible ways. So there are 5 times 4 times 3 times 2 times 1 ways to order any unordered hand. So whatever hand you've got, there are this many ways it could have come in order, and we don't care in what order it came. We're going to rearrange it the way we want anyway. So we'll divide the number of ordered possibilities by the number of possible orders in which every given set of 5 cards could be dealt in order, okay? And of course that gives us 30C5. And we won't go into the details of the factorial representation and so forth. That's addressed in some of the later problems, and we've been over that. So for how many 5 card hands? Basically we're picking 5 out of 30, and order doesn't matter. So the answer is there are 30C5 ways to do that. So that doesn't answer the given question, but that gives us a little bit of a feel for how we can answer questions of this nature. So let's go ahead and answer this question. Well, you should be thinking through these before you watch me do them. I keep reminding you of that. But in order to get exactly 5 card hand with exactly 2 character cards, what we need to do is we need to get 3 non-symbol cards. Now I'm using the word symbol and character. Symbol's a shorter word. So I'm going to say, let me write it in here. I'm going to use the word symbols for the characters, and we're talking about these 5 characters here. And we'll call these symbols also, so that the word symbols make sense down here. Okay, well, we need to get 3 non-symbol cards, 3 of the cards from here over. Okay, how many ways are there? And then we need to get 2 symbol cards. Now, how many ways are there to get 3 non-symbol cards? Well, 25C 3 ways. There are 25 non-symbol cards, and we got to get 3 of them. So that's how many ways there are. And there are 5C2 ways to get 2 of the 5 symbol cards. And we got to do both of them. So we're going to use the fundamental counting theorem the fundamental accounting principle, saying that, well, we got to do this and we got to do this. We're breaking this into a two-step problem. Get 3 non-symbol, 2 symbol cards. We're going to multiply this number by this number to get the total number of ways to get our hand. Okay?